Summarizing the parabola theory work for grade 11, you have these three formula to work with. This one is very useful at this stage, and when you sketch them, you need to remember to find these points and this line. To do the intercept, you do the usual, let x equal 0 for the y-intercept. To get the x-intercepts, you let y equal 0 and you solve for x. You then either get 2 points out or none, and you may get something that's irrational. If it's irrational, you estimate the position by using the decimal number on the calculator, but when you draw it, you label it with a surd. If you don't get any intercepts out, it's because the graph looks like that. So it has everything else, but it doesn't have x-intercepts. You're going to estimate it because you've got other information, and you're going to draw the shape. If you are required to use other points, then you are going to sub in to the formula some x values that you can see need to go in, and you are going to use the table method and plot another point. To draw the turning point and the axis of symmetry is the same calculation. You need to get it into this format, or if it is in this format, you can just use the turning point as negative whatever p is and then the q value. The axis of symmetry is then x equals negative p. For this one, this type of formula, you can find the x-coordinate of the turning point, which is also the axis of symmetry, as that formula, which you need to learn off by heart, and you can find the y-coordinate by substituting into the formula. Basic graph interpretation involves these few concepts. The domain and range need to be written in either set builder or interval notation. So you can choose how you want to do that, and you just need to remember that domain is all the x values, so along the horizontal, and the range is how far up and down. So you're going to read that off your graph and write it down for a few marks. Minimum or maximum value will simply be the turning point, minimum if it is a happy graph, and maximum if it is a sad graph. The values of x for which the graph increases or decreases is merely from negative infinity up to the turning point, and from the turning point up. If this graph was a sad graph, then it would increase up to the turning point and then decrease on the way down. Again, you're using set builder or interval notation. To find the equation of a graph, you need to be given some information, and then you're going to work out the variables for the equation. If you're given the x-intercepts and one other point, you need to use this special formula. If you're given the turning point and one other point, you can simply plug it into this formula and solve from there. When graphs are transformed and you are asked to transform something that you already have, or you are asked to explain how graphs have been transformed, you're going to look at the formulas. So you get given a formula and you're asked for a new one. They'll tell you to shift it up or down, or they'll tell you to reflect it. They could also give you two graphs and say, how has graph f of x been transformed to become graph g of x? And you're going to do the same thing, just backwards. Okay, so if it's shifted up and down, you are adding or subtracting from the q value. If it's shifted up, it is plussed, and if you shift it down, it is minused. This one's intuitive, this one's not. When you have the graph shifted left or right, remember you are adding to the left and you're subtracting to go to the right. When it's reflected in the y-axis, then all the x values must be negative, but when it's reflected in the x-axis, all the y values must be negative, which means that the entire equation needs to be multiplied through by -1. So you can leave the y as positive and multiply everything else through by -1. If you are given the line y equals x, you're going to swap the x and y values, and you're going to solve for y.